Alright, in problem number 1, we have these two squares, and they're congruent with sides of 8 units. And they're placed such that the vertex of one lies at the center of the other. Okay, so this point right here is the center of this square, and it's the vertex of the other square. And we're asked to find the area of the overlapping region, so this shaded region. Alright, so my hint to you on this one would be to imagine what would happen if this was a pivot point and we were, this square out here. Maybe I should make it some kind of color. Let's make it a color. We'll make it red. So let's pretend that the red square here is stationary, and that the green square, I'm going to make this one green, is allowed to pivot around the point, which is the center of the other square. So it's the vertex of the green square, and it's the center of the red square. Okay, so imagine what would happen if we pivoted that around, and what the overlapping region would look like as we pivot the green square around the red square, the center of the red square. Okay, so let's look at a couple different cases. This is at some sort of arbitrary angle, but let's look at the case where, let's see, I'm going to pick up a different color. Let's look at the case where the edges of the edges of the square meet at right angles. Okay, so that would be this case here. All right, so we're assuming that's a right angle, and try and draw this square so it's reasonably square looking. So let's look at it when the square is in this position. All right, I can't draw. All right, so that's the square, but it meets at right angles here and here. All right, and then assume these are straight. I don't know why I can't draw here. All right, so if we look at that case, it looks pretty obvious that the overlapping region. Let's see if I take a highlighter and I highlight. Let's use a different color, pink. How about if I highlight the overlapping region here? It's pretty obvious that this is a 1/4 of the square, right? Because if I were to draw lines like this, you can see that if we divide it in half and then half again, then we have quarters, and this is the overlapping region is 1/4 of the square. So let's look at a different case. Let's look at a case, let's see, pick up a purple pen now. Let's look at a case where again, we're pivoting the green square around the red square. So let's look at a case where the edge of the pivoting square goes through the vertex of the red square. Okay, and if that is a 90-degree angle, which we're told is a square, so it has to be a 90-degree angle, then it's also going to intersect the other vertices. All right, and so let's draw this rectangle out. Make it look decently. I guess it's not a rectangle, it's a square, right? Let's make it look reasonably square. So I'm going to erase this highlighting. And let's go to another highlighter. I like green. And you can see here this overlapping region, if I highlight it, is also 1/4 of the square. Okay, so given those two positions, we get 1/4 of the square. So the question is, what does it look like at any other angle? Okay, because you can see here, if I were to draw, divide the square this way across the diagonals, you can again divide it into quarters by cutting it in half diagonally. Okay, and you can see that this would be 1/4 of the square. Okay, so in those two positions we get 1/4 of the square. And So I'm going to get rid of some of this stuff here, and let's go back to something a little simpler. And let's look at what it would be anywhere in between. Okay, so I'm actually going to get rid of the highlighting here too. Oops. Yeah. All right, so let me switch back. I'm just going to go black, and let's take a look at it. As we swing this square, you know, here's the case where where it's intersecting at a 90-degree angle. Okay, so the sides are intersecting at a 90-degree angle here, and intersecting at a 90-degree angle here as well. All right, and you can see there's a triangle formed between the, you know, this position, this orange position of the square, and this green position. Okay, I guess some of my green got erased here. But there's an angle, okay, and as we swing the square around this pivot point, an angle opens up here between. It's a, you know, if we assume that this orange square is like the original position, and then we swing it, and this angle here is also going to be the same as that angle. Okay, so we actually end up with two congruent triangles. Okay, we have, you can see that this triangle, let me see if I can maybe mark it. Let's see, mark which one I'm talking about. So it's this triangle here. I'm going to try and color it in. Alright, and this triangle here are congruent. And why is it congruent? Why are they congruent? It's because of something called the ASA theorem. Okay, it's the angle side angle theorem. So you can see that this angle here and this angle here are congruent. These are both 90-degree angles, this one and this one. And the side between them, this side, which is the distance from the center to the edge of the square, and this side, which is the center, is the distance from the center to the edge of the square, are the same. So when we have two angles and the side between them, when those are all congruent, then we have congruent triangles. Okay, so these triangles have to be congruent, and so you can see that as we originally were sitting here with a quarter of the circle, and so as we swing the green square around, you can see that the area that's the overlapping area that's decreased here, this is the amount that's no longer part of the overlap, but the part that becomes now part of the overlap is the same area, okay, because these are congruent triangles, okay, and you know, it's hard to talk about when I don't have any labels like A, B, C, D. You know, if we were actually writing a proof of this, we would probably label, you know, maybe label this C for sender, and call this A, and call this B, and call this C, and call this D, and then it's easier to talk about then, because then we can say that, well, actually, we don't want that to be C. Let's call this O. Because if this is C, we can't have 2 points called C. Alright, so if we have the triangle ACO, and it's congruent to BDO. Alright, so the area of the overlap decreases by the area of ACO, but it increases by the area of ADO. Okay, this one up here. And so, you know, we started out at a quarter, and then we swung it by a certain degree, and you can see that the area is still going to be a quarter of a circle. So no matter what position this green triangle is in, as long as its vertex is at the center of the red square, what was the red square, then the overlapping region will be 1/4 of the square. Okay? So, alright, now back to our original question. The original question asked what is the area? So we have an 8 by 8. We have an 8 by 8 square, and so the area is going to be 64 square units, and 1/4 of that then is going to be 16 square units. Okay, so there you go. That's the answer, 16 square units.